For my project, I am examining the shot logs for players, and in this case, two specific players, the front runners for the MVP for the 2014-2015 season, James Harden and Stephen Curry. I uploaded the data and made sure to remove any rows that didn't have applicable values, for example, shot clock values that were not applicable. To start with, I wanted to examine the binary variable shot result, which told you whether or not a player made or missed a shot, and so I used logistic regression there. Um, and so shot result was my target variable, and then I picked specific attributes to be the independent variables that we were trying to use to explain. I used the stats model API just because I liked the results summary better. It was more complete. So to start with, we take a look at Steph Curry's shot log distribution and just kind of look at some of the distribution for the independent variables, specifically shot distances. You'll notice that he takes a lot of his shots in that 20 25 foot range, and actually a significant number of his shots beyond that in 30-foot range. And you'll notice that that difference is more significant when we take a look at James Harden's shot distribution. So we started with all 12 variables. Period 5 indicated overtime, and then we used feature selection. So I used k best equals 5, and then I narrowed it down to 4, and so on, until I got to the best features. However, in this case, feature selection is actually greedy. So feature selection actually only came down to 2 significant variables at some point. But when I actually looked at it manually, I noticed that there was a third variable, closest defender distance, that was important. And I felt it was more important to keep it in there because, as you'll see later, it's in James's model. And so it was a nice comparison between the two variables to see how they impacted the shot result. That, and when we look at Steph's model, you'll notice the coefficient for closest defender distance is actually the one with the greatest magnitude, still has the same significance as the other variables. And so it shows that the odds of Steph Curry making a shot is 23 times more likely with each increase in closest defender distance. So that's pretty significant, and that's actually an indicator of how difficult it is to guard Steph Curry. So we take a look at James's shot model, and you'll see the log shows that James doesn't have quite as many shots from 30 feet, has a lot more shots closer to the basket. And then so we did the same thing with James's model, where we used all 12 variables, used feature selection to narrow it down. And with James, we eventually narrowed it down to shot distance and closest defender distance. So for James, it was only 5.5 times more likely for each increase in closest defender distance that he would make the shot, which is a significant difference from Steph's 24 times more likely. The other thing I wanted to examine was the final margin, and so to do that, I used linear regression to examine how the shooting statistics affected that. I aggregated the data by game, and then took the mean of most of the variables except for the shot number, which I took the count of total shots. And so we'll see that the adjusted R-squared on our initial model is 0.19, which is actually pretty low. This speaks to how difficult it is to determine a final margin based off of an individual player. You'll see that it doesn't get much better, actually, but it still stays around that low range, and that's an indicator of how difficult it is to actually predict final margin based off of one player. So eventually we narrowed down just 2 significant variables, and those variables are shot number, which actually represents the total number of shots in that game, and shot result, which represents the number of made shots versus the total shots. In this case, when Steph Curry is really accurate, the margin goes up a lot, because you'll notice shot number is actually a negative. So the less shots he can take, but if he can take shots that are more accurate and make more of them, his team does tremendously better. So we take a look at the residual data just to see what it would look like after splitting the data into train and test and predicting. And you'll see, based on the predictions for the residuals, that there is no distinguishable pattern. So that kind of confirms that the variables for number of shots, and in this case field goal percentage, are linear if you kind of take out this outlier here. And then for James, you kind of see the same thing, except for the 2 variables for James that were significant were shot result and shot clock. So, and then in the future, what I'd like to do is take a look at the team overall versus the final margin. I think it would be more useful. and probably a lot more accurate with regards to the adjusted R squared value.